how long my net connection will work. Okay, so let me start the example directly. So today also I'm going to design a Turing machine. Today also I'm going to design a purposely I'm doing very slowly. Okay, why I'm doing this one means you please go back and then practice as much as you can. Okay, that's why I'm moving a little bit slowly. But once you understand this Turing machine, right, it's very interesting. So let me begin. Stuff I cannot cancel directly, so it's eating up my time here. Okay, fine. So today we are going to design a Turing machine which is going to accept. So we are going to design a Turing machine which is going to accept the language of 0 to the power n, 1 to the power n. So before I begin like designing the Turing machine, right, let's just try to understand this language first. So what are the languages consist with this particular language are? Number of zeros is equivalent to number of one. So 0, 1 will be accepted, 0, 0, 1, 1 will be accepted, 0, 0, 0, 1, 1, 1 will be accepted, then 0, 0, 0, 0, 1, 1, 1, 1 will be accepted. And then yesterday, I have already mentioned that while designing a Turing machine, you have to specify the rejection state and acceptance state separately, very clearly. And then, like we have seen in the case of finite automata and all, once you have a final state, you can have a self loop or maybe further extension of another state and all like that. But in the case of Turing machine, once you reach either this is kind of whole state, okay? Once you reach either acceptance final state or maybe rejectance final state, you cannot proceed further. That's the main differences between the type of final state which we are seeing in the case of Turing machine and the type of final state which we are seeing in the case of finite automata. So now I'm going to design a Turing machine which is going to accept such language. Now, before we begin the designing part, right, let me just take one string. Let me just take one string here. 0, 0, 0, 1, 1, 1. Hash is going to represent the blank symbol. Now, initially what I'm going to do is, I'm going to start from here. Initially, I'm going to start from here. This is Q0. Okay. Initially, I'm going to start from here. This is Q0. And then whenever I come across 0, right? Whenever I read 0 from the input tab, what I'm going to do is, I'm going to replace this by, let me use different color. I'm going to replace this 0 by symbol A. I'm going to replace this by symbol A. Now, after reading this 0 from the input tab and then replacing this 0 by the symbol capital A, I'm going to move towards right side. This read write head will keep on moving towards right side. If it finds 0, it won't change anything. Again, it will move towards right side. If it finds 0, it won't change anything. After that, again, it will move, then it will find 1. When you find 1, what it's going to do is, it's going to replace this 1 by capital C. Okay, why I'm not using B? If you want, okay, fine, I'm using hash for representing blank symbols, so I'll just use B for this one. B maximum of the time it's being utilized for representing blank symbols, so I thought of avoiding that one. So let me use B here. So if I right, if I find 1, right, I'll just now after finding what I'm planning to do is start moving towards left side. Towards left side, if you start, you find 0, don't do anything. Just keep moving towards left. Again, if you find 0, don't do anything. Keep moving towards right side. When I move towards left side, I'm finding the symbol A. When you find the symbol A, right, then move towards right side. So if you, after finding this A, if you find this 0, then replace this 0 by A and then repeat the process. While repeating the process, right, for moving towards right side, if you find 0, leave it as it is. Again, if you find B, leave it as it is, keep moving towards right side. If you move towards right side, if you find 1, then replace by B. Again, come back. Okay, this is the procedures. It's going to happen till we find this hash. Okay, so now let me start designing the Turing machine for this. Turing machine, please practice as much as you can. It's very interesting. Okay, so now let me begin the designing part. So in the designing part, right, I'm going to start from Q0. I'm going to start from Q0. From Q0, right, initially what I'm planning is wherever I find 0, I just want to replace this 0 by symbol A, and then I just want to move towards right side. Okay, and then when I'm moving towards right side, right, while moving towards right side, after the first 0, how many zeros I'm finding? I'm finding 2 number of zeros. Okay, I'm finding 2 number of zeros. But if you keep, if while moving towards the right side, if you're finding 0, don't do anything. The first 0, what you did, you have replaced the first 0 by the symbol capital A. After that, the second and third, right, you're not disturbing, you're not doing anything. So what I'm going to do is, I'm going to keep a self loop here. The first 0 I have converted to capital A. I have replaced this 0 by symbol A. The second and third, right, what I'm doing is, I'm not doing anything. I'm just leaving this as it is. And then I'm keep on moving towards right side. So this is a self loop. Whether it's going to be a 2 times of 0 or 3 times of 0, whatever n number of zeros, it's not going to disturb anything. It will keep on scanning and then it will be moving towards right side. This is step Q1. Now, next one, after the first 0 is replaced by the symbol capital A, after that, the second and third 0, if you are scanning it, we are not doing anything, we are not modifying anything. So we are moving, we keep on moving towards right side till we find this character 1, this input symbol 1 from the input tab. So now what I'm going to do is, if I find 1 here, what I'm going to do is I'm going to replace this 1 by symbol B, and then I'm going to move towards left side. I'm going to move towards left side. Now again, what I told, I'm going to replace the first 0 by capital A. After that, the second and third, I'm not going to disturb them as it is. I'm going to leave them as it is. I'm going to keep scanning till I find the first one. When I find the first one, right, what I'm going to do is, I'm replacing this 1 by the symbol B, and then immediately I've started moving towards the left side. Now, when I move towards the left side, right, when I move towards the left side, I'm going to find many number of zeros. In my case, right now, I'm going to find 2 number of zeros. I'm not going to disturb those zeros. I'm going to leave this one as it is. So now what I'm going to do is, this is Q2, and then I'll be having a self loop. If you find any number of 0 here, if you find any number of, while returning back, while moving towards the left side, if you find any number of zeros, leave it as it is and then keep moving towards left side. And then keep moving towards left side. Now, what happened is, now when I keep moving towards left side, if I find 0, I'm not disturbing it. I'm leaving that 0 as it is, and then I keep on moving towards left side. The third 0, again, the second 0, this is the first 0, while moving towards disturbing it, I'm leaving this, not disturbing it, I'm leaving this as the third one, right? The next one I'm going to find a symbol capital A because I have already replaced this by capital A. So when I find this capital A, right? When I find this capital A, once I find this capital A, I'll start moving towards right side immediately. So what I'm going to do is from here to this. If I find the symbol A, let it be A as it is, and then start moving towards right side. Okay. Now, after finding A here, I have started moving towards right side. Once I find this A, and then when I move to right side, if I find 0, I'm going to start repeat from here. So this 0 will be replaced by capital A. This is the transition here. After that, on the way back, on the way moving towards right side, if you find 0, leave it as it is till you find 1. But while returning for this part, right, let me draw the diagram again. For this part alone, let me draw the diagram. This is replaced by A, this is 0, this is 0, this is B, this is 1, this is 1, hash. Now, after finding this A, I'll start moving towards right side. If after finding this A and then I keep on moving towards right side, the first 0 will be replaced by A. After that, the second one will not be disturbed. It will be remain as it is. While coming back, while returning, while moving towards right side, now the another symbol we are going to find, which is B. B also we are not going to disturb anything till we find 1. Okay, so here after replacing this 0 by A, while returning back in search of this 1, I'm going to scan this symbol B. So if you find this symbol B, we are going to leave that B as it is and then keep moving towards right side. Okay, this is the scenario here. And then after finding this B, and then the next one, if I find 1, I'm replacing this one by capital B. This is done here. And then I have started moving towards left side here. So after moving back towards the left side again, we are going to find B and 0 here. For 0, we have already written here. So let me write, if you find B there, leave it as it is, keep moving towards left side. After that, if you find the first A here, this is the transition here, and then come back like this. Okay, this is the repeated pattern. This is the one. Now, what about when are we supposed to accept? When are we supposed to accept the language? The language will be accepted. Let me draw the diagram. In what case we are going to accept the language? So once we scan everything, right, this will become A. This will become B. So the last, let me write like this. Now the last one, right? 1 and then hash. Now, while returning back, right? When you find this one, I'm going to replace this one by B, and then I'll be moving towards left side till I find first A. The first A is here, till I find the first A. Now, after finding this first A, immediately we are going to move towards right side. When I move towards right side, if I find the symbol B, it means what? All the 0 are being replaced by A, it's completed. That's why we are not finding any 0. So after this A transition, right, if you find this B, then it means you are in the verse of acceptance. Okay, so now, so we are not going to stop there. When you find this B here, again, if you keep on moving, if you find only the B, if you find only the B symbol, till you find hash, then you're going to reach the acceptance stage. If suppose, let me tell you something. A, B, then after replacing 1 by returning in here like this, in here, hash, if you find 1, then this will be rejected because number of B's has to be equivalent in nature for this particular language. So now for acceptance, right? After converting the last A, while moving towards the right side, instead of finding 0 here, if you find B, instead of finding 0, if you find B, do not modify this B, keep moving towards right side. Okay, keep moving towards right side. 2, 3. Now again, while moving towards right side, you're going to find many number of B's. You're going to find many numbers of B's. Okay, like this, after finding this A, I'm going to move towards right side. You have come along with the first B and then many number of B's here. So let me just write B, B, keep moving towards right side. Now, if I keep on moving with this number of B's, and then next, if I find hash, leave it as it is, hash. If you want to move towards right side, it's fine. Then you're going to have the acceptance state. You're going to have the Q accept. You're going to have the Q accept. It means what? It means what? Let me draw the diagram. A, 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 B, 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 hash. After reaching this A, if you keep moving and scanning for all the B's still without finding any ones, if you find hash, it means you have replaced all the zeros and ones by equal number of symbols. And then instead of hash, if there is no one, then it means the number of zeros and ones are equivalent. Hence, this is going to be accepted. And if you find hash, then don't disturb that one. Just leave it as it is, hash. If you want to move towards right side or maybe not, doesn't want to move, and you're going to reach the final state, Q final state. Acceptance, final state, acceptance. And then again, I have already mentioned that for Turing machines, right, you need to specify the rejection state and acceptance state very clearly. So again, I need to insert the rejection reading this A back, if suppose instead of finding hash, before this hash, if you find one, before this hash, if you find one, then it means what? The number of zeros and number of ones are not equivalent, and this has to be rejected. So I'm going to insert the rejection part here instead of hash. If I find one, do not replace with any symbol. Just keep moving towards right side and then just go to the rejection state. Q reject. Okay. And then if you find one here, it means number of ones is greater than number of zeros. If suppose the situation is such that 0, 0, 0, 1, 1 hash. Okay, this needs to be rejected. For this one, right, let me draw the diagram and then explain it. Because rejection state needs to be specified very clearly, both the rejection and acceptance state in the case of Turing machine. So we need to provide the rejection state also in a very detailed way. Now let me draw the diagram. For this particular rejection state, this is for when number of ones is greater than number of zeros. Now we need to insert the rejection for when number of zeros is greater than number of one. So let me just draw it, 0, 0, 0, 1, 1 hash. Now let me use different color here. Now at first, if you find 0, initially it starts from here, Q naught. If you find 0, replace by A, and then keep on scanning it till you find the first A. If you find this first A, replace by B, and then keep moving towards left side till you find A. Once you find A, keep moving towards right side and then replace this one by A. Now scan it. If you find 0 or B, whatever, don't disturb it. Just keep moving. Once you find 1, replace by B. Again, once you find B, come back, move towards left side. If you find B, do not disturb it, leave it as it is. If you find 0, do not disturb it, leave it as it is, till you find A. Till you find A. Once you find A, just come back to the right side. If you after reaching A, if you move towards right side, if you find 0, then replace by A. Replace by A, scan it till you find 1, till you find 1. But instead of finding 1, if you find has, reject it. Right? This is another rejection case, we need to insert it. So where we need to insert it? Where we need to modify it? This is just note it down, just note it down. I have explained in my diagram, right? In my Turing machine diagram, if number of 1 is greater than number of zeros, that this Turing machine will be rejecting this string or this language, okay? But if number of zeros is greater than number of 1, this has to be rejected. And then I have explained the scenario here. So what you need to do is you need to modify it in this particular diagram. You need to modify it in this particular diagram. So where you need to do the modification. Where you need to do the modification. So in my case, let me just insert it in this one. In this one, we need to do the modification here. This. If you find hash, don't disturb it, leave it as it is, keep moving right side. Okay, at Q1, you need to do the modification. Please check it. Please check it. Okay, please check it. I've used different color. You need to specify both the rejection state and acceptance state in the case of Turing machine. Okay, so I'm going to end the class here. Now see here, I'm going to upload the assignment both for Turing machine and push-down automata. And then hope this is going to be the last class for this week. Enjoy Holly. Once return back, right, I'm going to conduct series of tests, and then I'll continue these Turing machine classes, and then submit the assignment. Assignment submission, right, I'll extend it, don't worry. Enjoy the Holly for 2 days or something. After that, you just submit the assignment, okay? So this is going to be the last class for this week, I guess. So from Sunday onwards is Holly, right? Happy Holly, everyone, and keep doing your assignment and all. I'm going to give a lot of assignment for this one, okay? Both for
Thank you, ma'am.
Yeah. Bye. Happy Holly.
Bye.